achieved successfully. No one had ever poured this much concrete at the same time before. It was only the first world record broken by the Petronas Towers. 1994 dawned, and at last the two tower teams could move in. The race to the top was on. It was a fight from the start.
We got the head start. Tower 1 started first.
Bob Pratt in Tower 1 got a head start of a month. It looked like John Dunsford's chances of winning the tallest building prize had already been snatched from his grasp. He took it coolly.
Was I disappointed that we started 30 days behind? It was part of the plan. And on 3 years, 4 years of your life, 30 days don't really make that much difference.
The builders on both towers ran into trouble right from the start. They had serious teething problems.
The first few months of our operation was a disaster.
Nothing went right. The schedule said each of the 88 floors had to be built in only 4 days. Right now, it was taking them 8. The sense of rivalry was mounting.
That's probably the first time there was ever a dialogue of you lost time against the other tower.
The difference was clear. Bob Pratt's Tower 1 was winning over John Dunsford's Tower 2.
They definitely hit their stride and started to pull ahead.
It was very exciting. You could stand back literally week by week and watch this thing grow on the skyline of Malaysia.
Speed was vital if the builders were to meet their deadline, but the smallest error could weaken the building's structure and wreck the whole project. The team were forced to use a new construction method, so the risk of mistakes was even higher. Nobody had ever tried it on a mega skyscraper before. A normal skyscraper hangs off a steel frame built of girders that supports the weight of the building. Steel made the first skyscrapers possible. It's immensely strong, but also has a slight flex, something tall buildings need. But Malaysia didn't have a big enough steel industry, and importing it would blow the budget to pieces. What Malaysia did have was concrete, vast amounts of it. It was the only way Petronas could be built. Not only was this the tallest building on Earth, they'd be using a material never tried out on this scale before, an untested technology. Instead of a steel frame to support the weight of the building, the Petronas towers would use a ring of 16 concrete pillars linked by beams. Between them, they would have to support 270,000 tons, 7.5 times the weight of the Titanic. No one had ever done this with concrete before. Malaysia's previous tallest building was just 250 meters high. The Petronas towers were going to be nearly twice that. Conventional concrete would disintegrate under the load. The Petronas engineers needed a new formula. Concrete that could do the job of steel. It didn't just have to be strong. For an ultra-tall building, there had to be a degree of flexibility. Chicago is the home of the skyscraper. Close to the city is CTL, one of the world's largest concrete testing laboratories. With concrete, tiny changes in the recipe can make a huge difference to how it performs under pressure. And the Petronas towers would certainly push it to breaking point, if not beyond. As if that wasn't enough, they could only use raw materials locally to hand in Malaysia. The mix was essential. Just a pinch too much of one material could be disastrous. In the lab, scientists worked their magic with the most basic ingredients: gravel, water, cement. They started with the recipe they knew, using Malaysian materials in the same quantities they used in the States. For the test block, it was the moment of truth. The concrete for Petronas had to withstand 20,000 pounds a square inch. The 600 mark on this dial. This small column of concrete needed to carry the equivalent of 20 trucks. The crushing weight was immense. 200 on the dial wouldn't even be strong enough for a 20-story building. 350 could support half the Petronas towers. It wasn't good enough. It was back to the drawing board for the concrete wizards. They had to redesign the mix from scratch. They were making progress, but it wasn't strong enough to match the demands of the Petronas design. The entire project depended on getting this right. They tried high-tech additives such as silica, left over from computer manufacture, which reduced air bubbles in the concrete, making it stronger. It was their last hope. Finally, success. The team were delighted. They had their super strong material. And they needed it. A concrete Petronas Towers was going to be twice as heavy as a steel one. With the concrete problem solved, the teams threw themselves into the race against time. Constructing each floor was a logistical nightmare. Up to 2,000 workers, tons of concrete and heavy equipment, all moving in perfect harmony. It was a complex process. Build the support pillars, lay the floor, move on up to the next level and repeat the process all over again. As the floors rose, the outside of the building was laboriously slotted into position, an enormous 88-story jigsaw puzzle. The complexity was immense, but things seemed to be going well. Then, a batch of the super strong concrete went for routine testing, and it failed. Concrete being delivered to the building wasn't strong enough. Somebody hadn't stuck to the recipe. So, the vital question, had any of the dud batch already been built into the towers? Work came to a dead halt. If they went ahead with the wrong concrete, the results could be disastrous. Krish Krishnaswamy had the tough job of making sure the concrete lived up to its exacting specs. If they had to rip the towers apart, it could mean financial meltdown.
Oh, there were a lot of disagreements, a lot of arguments.
Further investigations were slightly more encouraging. The bad concrete had only been laid on one floor. Krish Krishnaswamy ordered the contractors to rip it out and start again.
It was a very stressful day.
It had been a narrow escape. If the faulty batch of concrete hadn't been discovered, the results would have been unimaginable. The testing facilities were upgraded. 3 concrete plants right on site meant a problem with one wouldn't hold up the whole operation. Every batch would now be tested to the limit before being poured into the towers. Precious time had been lost. They were taking the towers apart before they'd even built them. For Chief Engineer Charlie Thornton, it was embarrassing and expensive.
That hurts your ego, it hurts your sense of satisfaction, it can also hurt your pocketbook.
More important for the 2 construction teams, they were struggling to stay on schedule. And if they didn't want to face hefty penalties, they were going to have to make up time, and fast.